In this unit, we have learned to add polynomials, subtract polynomials, multiply polynomials. So the logical thing would be, the next would be to divide polynomials. We're doing it in a different way, and we're calling it GCF. So what we're doing is, on this one, we're going to undistribute. So if you had 3 times x plus 2, you have learned in earlier classes, and this class, to have that as 3x plus 6. Now you're going to start with 3x plus 6, and you're going to have to look at it and say what's common in 3x and 6 in the terms, and you're going to say 3, and then you're going to factor out the 3 in both terms and go back to x plus 2. So you're undistributing, and you can look at it that way. But what you're doing is you're taking out the greatest common factor. In your parentheses at the very end, look at what's in your parentheses and see if there's anything that you missed. So if I look at 5m squared minus 9, I can see that there's a 3, because 3 goes into 15 and 3 goes into 9. And nothing, this doesn't have an m. So if I divide 15 by 3, I get 5m squared. If I divide negative 9 by 3, I get minus 3. When I look inside my parentheses, this is prime and this is prime, so another number doesn't come out, and m is not in the last term, so this is your final answer. You can check yourself. So I look at my numbers, and I have a 5 and a 10. I know a 5 comes out. I have 2 x's here and 1 here. I can pull out an x. 5x times what gives me 5x squared, which would be x, because 5x times x would give me 5x squared, plus 5x times what gives me 10x, and that would be 2. So, and I'm dividing kind of in my head. So 5x times x would give me 5x squared, 5x times 2 would give me 10x. I have it. I look through here, I have 4, 6, and 14. That's 2s, that's 2 and a 3, 2 and a 7, so only a 2 can come out. There's 5, there's 3, there's 1, only one of them can come out. So 2 times 2 gives me 4. 1 here, 5 here, leaves me with 4 of them. Sign stays, because I didn't take out a sign. 6 times 3 is 6. There's 1x here, there's 3 here, 2 left in. And 14 divided by 2 is 7, and the x came out. And then when I look at this, I double check in a 2, a 3, and a 7, they're all prime, so nothing else comes out numerically. And this doesn't have an x, so x's don't come out. I also can go 4x to the 5th, 6x cubed, and 14x and end up. So you can check these. Everybody has a negative. I can take the negative out. It's common to everybody. 8 and 12 has a factor of 4. And a squared, a2 and a, I can pull out an a. B and b2, I can pull out a b. C2 and c2, I can pull out both c's. Negative 4, negative 8 divided by negative 4 is 2. 1 of them here, 2 of them here, 1 stays in. The b came out, and the c came out. Positive. Negative 12 divided by negative 4 is positive 3. The a came out, 1 of the b's came out, and all of the c's. And if I went back in and distributed, I'd end up back here. You can do it for multiple terms. So I have a 3, a 9, and a 6. I'm going to take a 3 out. Ooh. And you can do this in other steps. So I have a 3 that's common. x4, x3, x2. x2 is the greatest common factor. This one doesn't have y's, so I can't take out any y's. 3x to the 4th, 3x squared. That means there was an x squared left. negative 9 divided by negative 3 is negative 3. X cubed, x squared, there's got to be one more. The y wasn't touched. 6 divided by 3 is 2. X squared, there's the x squared, and y squared has to stay in. This one is take a 5 out because 5 goes into 15. I keep trying to do it in multiple steps. 15, 5 goes into 15 and 20. X cubed, x squared is the largest that can be taken out. Y squared, y can take out. Z squared, z can take out. 15 divided by 5 is 3. 3 of them, 2 of them, 1 has to stay. 2 of them, 1 of them, 1 has to stay. And the z, oh, nope, the z got taken out. And then this would be plus 20 divided by 5 is 4. X squared, y, z squared, so only a z was left. That is GCF, factoring out of terms. You are going to have to get good at this because when your answer, this would not be a final answer. That wouldn't be acceptable. You would actually have to write it like this to show that that is the simplest form. And this is considered simpler than that. That is page 1 of 11-6, greatest common factor, or GCF again.